All right, so what we're going to talk about now is passwords. Let's say we do something like this. Obviously, that's not secure. But end users do this all the time. You say, give us a strong password, and they type something like password. Well, what does that do? It makes your program look weak because somebody was able to just simply type in the word password and boom, they get access to all the data. End users don't simply understand how security works. So for this example, a few things I want to point out. First thing, we've already got Pointy Castle installed, and we've got our imports in place. So we're importing the convert, type data, and Pointy Castle. What we're going to do is we're going to actually derive a key. To do that, we need to actually use some algorithms. Let's make some helper functions first. We're going to say uint8 list. Longest function name ever, I know, forgive me. And we're going to say string value. And we're going to just simply do this. And we're going to give it the utf8.encode. So what that's going to do is save us a little bit of type in the future. We're going to reuse this function in future tutorials. And we're also going to make a simple display one too. So we'll say void display. And we want to give it a string title. All right, so first thing we're going to do is print this out. Let's print out the title. And then let's print out the value. Value is most likely going to be not human readable, so let's just print it out as a base64 encoded object. And then let's just print out a blank line. That way, if we print multiple in a row, we have a nice blank line separating them. All right. Now, let's make a salt. And we're going to explain what that is in just a bit. We're going to make a key derivative, and we want to give it some algorithm names. In this case, we're going to say sha1 hmac / pbk df2. And if you have no idea what that is, congratulations, you are among the majority of the population of the world. What those are simply algorithms. We're just doing some chaining here. We're going to push it through sh1, hmac, and we're going to use the pbk df2. You do not need to know what these are. That's the beauty of this framework. You just need to understand that you're pushing it to an algorithm. All right. Now we're going to say some params here. We want the parameters. And notice how we want a salt. We want an iteration count, so we're going to say 100 iterations. And we want the desired key length to be 16. That is critical. It's because it uses a block size. So if you do something other than 16, it's probably not going to work. And you're going to get an error message or some other weirdness is going to happen. All right, so we are going to say pkcs dot, and we're going to init this with our params. So what this does is actually initializes those algorithms with the parameters that we've just set. Now we want to make a uint8 list, and we're going to call this our key. And we're going to say pkcs, and we want to call process. And what we want to do here is create from that password. And then let's just display it. Let's go ahead and run this. And you can see the key value is actually this now instead of the plain text password, and that's its base64 encoding. This is much more secure than just the word password. Now, what is salt? Remember I said I was going to explain what salt is. Well, let's say you write a program and your friend writes a program and you use the same algorithm. Well, you're going to get the same key, the same results. It's not very secure. So what the salt does is actually takes the same algorithm and randomizes it a bit. So you could actually say salt with a capital T. And let's run this. And you can see how the numbers are totally different now. Same thing, different salt. So think of the salt as like a key for the key or an initializer.